So yeah, the first topic today is specific impulse. Specific impulse and range. Okay, specific impulse and range. Now, a specific impulse is basically known as ISP. ISP. So ISP is defined as thrust produced per unit fuel weight per unit fuel weight per unit fuel weight flow rate okay. Per unit fuel weight flow rate. Now so thrust produced per unit fuel weight flow rate, that means ISP equal to thrust produced means T. We are taking thrust as F, na? So thrust and fuel weight flow rate. So fuel per unit fuel weight flow rate. So mass flow rate of fuel into G Okay, this we can consider it. Okay. Now let me give you the idea. Now consider an aircraft at steady level flight condition. Then what will happen? It will be T equal to D, right? Thrust equal to drag and lift equal to weight. That is the formula, right? Now, so thrust means here F, here we are taking thrust equal to drag, which is equal to basically, you can say now that it is basically L upon D. Can anyone tell me L upon D is what? L upon D. This is basically kind of D. Drag can be written in this particular way. If I write L upon D, then it can be basically converted into D. At the place of L, I can write W upon L by D. Okay. Now, what is weight? Weight is basically mass of aircraft into G divided by L by D. Right. Now, MAC is what? MAC is mass of aircraft at an instant of time. Mass of aircraft at any instant of time. Now, what is mass fuel flow rate? Fuel mass flow rate is basically d by dt of mass of fuel, which can be called as minus d by dt of mass of aircraft. Now, what does this mean? This means that change of rate of fuel is basically negative change of rate of aircraft. When aircraft is loaded with fuel, fuel is basically decreasing. So when fuel is decreasing, then aircraft weight is also decreasing, no? Okay, so that's why it's negative. Okay, so at the place of m fuel, we can write this formula. So you can see this is ISP. So at the place of ISP, we can go for ISP equal to F upon m dot fuel into G. So here F upon, at the place of m by mass flow rate of fuel, we can write this. This is what? This is okay. In the next line, I will write. Next page. So one thing, remember, F equal to this is. So F equal to this. At the place of m fuel is this. So I will be writing ISP equal to F upon m fuel into G. So it will be basically F is basically what? F is MAC G upon L by D. MAC mass of aircraft into G by L by D. This is the one thing which is F. Then m fuel, here G into m fuel. Now m fuel is basically what? It is minus d by dt of MAC, right? Minus d by dt of MAC. This is the bigger fraction. So upper fraction and lower fraction, this kind of thing, right? From here, if I solve, let's multiply this with ISP. So it will be ISP into G into minus d by dt of MAC equal to MAC into G by L by D. Now this G will be cancelled out, okay, and ISP can go there, okay. and minus sign can also be go there. So it will be called d by dt of mac, and how the mass of aircraft is changing basically. This is equal to minus mac by isp into L by d, into L by d. Right. So this is basically how much mass of aircraft change is basically there. You can say this is equation number A. Okay, A, B, C, D is not good for here because here we are using very much numerical, so it can be called as 1. Now, second concept is if ds is distance traveled. Now we are talking about range. Right? So if distance traveled is ds in time dt, then we all know that we can write like this: dmac by dt can be written as dmac by ds into ds by dt, right? We can write this thing. It's a basic mathematics, and from here you can say what is ds by dt. Ds by dt is basically speed, so u into dmac by ds. This is what dmac by dt. So at the place of dmac by this, we can write this. So here I will write at the place of dmac by dt, it is u into dmac by ds. Okay. So this can be called as equation number 2. Now equation number 1 and equation number 2, what I will be doing is here at the place of d by dt mac, I can write this u into dmac by ds equal to minus mac by isp L by d. Now again rearranging, I can write here rearranging, I can say dmac by mac. Now it's the case, na? dmac by mac. That's like solving differential equation. So dmac by dmac equal to minus ds upon this u will also go into this. So see, mac is coming downward, ds is going this way, and this u is also going downward. So minus ds upon u into isp into L by d. This is the rearranging thing. Okay, rearranging thing. So I can make equation number 3. Now from equation number 3, it is basically dmac by mac equal to minus ds upon uisp L by d, right? So we can solve it. Now in steady and level flight, what things are constant? We all know that u, isp and L by d, these are constants. Constant. So final formula we will be getting is basically this. If you solve it, it will be basically ln mac2 by mac1, and that means kind of after minus previous, minus here it will be s2 minus s1 divided by uisp L by d. Now if I have to calculate s2 minus s1, so s2 minus s1 can be calculated at this minus will be going this side, and when minus of ln will be there, then this will be changed. It will be basically, I am writing here so that you don't get confused. So minus of ln of mac2 by mac1, this will be basically ln of mac1 upon mac2, right? So this denominator changes. So it's basically uisp L by d ln mac1 by mac1 by mac2. Great. So this is the basically formula. Now what is mac1, what is mac2? We all know this for this thing. mac1 means gross weight, gross mass, you can say, gross mass, and mac2 basically means mac1 minus mf, right? Mf means fuel. If you decrease the fuel, that is basically mac2. Now what is mfuel? Mfuel is mass of fuel burned during the flight. Okay, one thing Kavya missed that day, but it's like this. Overall efficiency. Overall efficiency formula is basically, first of all, this is a great formula. You can learn this formula. Sometimes, I think only one time in the whole GATE history, this type of question has been asked. Like you have to calculate the range of aircraft when a specific impulse is given. Otherwise, you know the formula. That range equal to what was the formula? 1 upon CT, CL by CD, and ln W not by W1. That was kind of formula, no? In the range of sorry, range of jet aircraft is very large formula. CL to the power 1 by 2 by CD kind of formula, no? Very large. So in overall efficiency, the formula is basically eta naught equal to thrust power, which is F into U by M fuel into QR. M fuel into QR. So from here also we can just make some kind of formula. And finally, what we will be getting, I'm giving you. Finally, we will be get the formula S2 minus S1 equal to eta naught QR by G, QR by G, L by D, L by D, ln MAC by MAC minus MQ, basically MAC2 by MAC1, MAC minus MQ. So this will be the final formula. Okay. So here we can say that range is directly proportional to overall efficiency, Okay. And here also you can say that range is also directly proportional to specific impulse. If specific impulse is high, then range is high. If specific impulse is low, then range is low. Okay. So these are some MCQ, MSQ type of questions. Okay. Like I can say now, there are four options. Okay. Let me give you this question itself. Suppose there is an MSQ question. MSQ question is range of a jet aircraft in steady level flight is always proportional to now option number A is specific impulse. Option number 2 is thrust of aircraft. Option number C is basically what you can say. Option number 3, yeah, overall efficiency. And option number D is lift to drag ratio. I'm giving 1 minute. Just give me the answer and give me in the chats what is the correct answer. AC, then AC and D. Okay, all the options are correct. Every option is correct. Like, see, what is the formula? Formula is range is equal to UISP L by D ln MAC upon MAC minus MF. This is the formula, right? Okay, so range is proportional to ISP. That is correct. Range is sorry, eta naught is also there. No. Two formulas were there. One formula is this, and another formula is that range equal to eta naught QR by G. This is basically MAC2 minus MAC. Oh, sorry. One problem was there. In the first formula, it was MAC1 by MAC2. So MAC1 basically here. And in this formula, eta naught QR by G, L by G, ln MAC by MAC minus MF. This was the point. So if you see, it will be, yeah, range is proportional to ISP, right? Range is proportional to thrust of aircraft. So ISP, what is ISP formula? ISP formula is basically thrust upon G into MF. So if anything is proportional to ISP, that is automatically proportional to thrust. Then it is proportional to overall efficiency also, right? Then proportional to lift to drag ratio also, right? So all the options are correct. In this multiple select question, where all the options are correct, if you miss to choose any single option, no marks, 0. So that's the beauty of multiple select question. Okay, that either 1 marks or 0 marks. Yeah. How thrust? Yes. That's what I said, Nakavya. ISP, it is proportional to ISP. That when ISP increases, range increases. But when ISP increases when thrust increases. So technically, when 1 is dependent to 2 and 2 is dependent to 3, so 1 is directly dependent to 3. Okay, so that is the case. Okay, that's the kind of hidden thing. They can also say like lift upon drag is there, na? they can say that it is proportional to lift coefficient. So when anything L by D is given, then lift coefficient is also there. So they can play the tricks. Okay. Now this is a kind of MSQ, multiple personality questions people can ask. Now the next thing that we are going to see is basically gas turbine cycles. Now gas turbine cycles, we will not go into the very much detail because it's thermodynamics topics and mechanical engineering topic, but a little bit we will see. So what is gas turbine first of all? Okay, so any gas turbine is basically three things: compression, compression unit plus combustion unit. Now this is the beauty of this course, that you are going from plus zero. Otherwise, from the crash course, we will start from the like what is gas turbine. We will just draw the diagram and see compression, combustion, and expansion unit. Okay, so compression unit, combustion unit, and expansion unit. If I will try to make this thing, this kind of thing is basically kind of compressors. Compressors, and this can be called as combustion chambers. Combustion chambers, and this can be called a turbine, expansion unit. Now others are also there. Other, it's not like only three. Others are also like inlets are there, nozzles are there, afterburner is there, a heat exchanger, intercooler, various types of things are there. So basically what's happening is that if I draw kind of thing, it will be something like, okay, not this bad. So technically this is kind of thing, this is called casing and it's inlet. Okay, this is inlet. And sometimes it's also called diffuser. Whenever you heard the word diffuser, that is basically inlet. So after some inlet, there is a thing called compressor. Suppose compressor is from here to here. Okay. So compressor has various kind of thing. I will making the axial compressor. So axial compressor has various stages. So we can say stator, rotor, kind of thing. One is like this. So another will be like opposite one, stator then rotor. Stator means something which does not move, and rotor means something which moves. Okay, so this kind of something like compressor. Before compressor, there is a thing called inlet guide vanes. This is known as IGV, inlet guide vanes. And this thing is basically known as axial compressor. Axial compressor. Then after here, there is a whole section of combustion chamber. Okay, whole section of combustion chamber. So, like here, some IGV, inlet guide vanes, means the air which is coming, its pressure is little bit reducing. Okay, its pressure is little bit reducing. In the diffuser, speed is also reducing, and in compressor, its pressure is increasing, very much increasing. So high pressure gas is going in combustion chamber. In combustion chamber, what kind of thing is there? It's there like this is there, and this is the flame holders. Flame holders are there. Okay. See, other engines have other kind of thing. Flame holders means this is where combustion takes place. Fuel injector also you can see, fuel injector. Okay, so this is basically combustion chamber. After that, then there is a turbine. So in turbine, what happens? Just opposite of it. Again, here stator rotor, here rotor stator will be there. So basically, rotor stator. Although it will have less stages. If compressor has say 14 stages, it will have 7 to 8. So this is basically turbine. So first, high velocity gas, whose velocity has been decreased, but pressure increased. High pressure gas is going into the combustion chamber, now heated. Now this gas is high pressure and high temperature, both. Then it is going to turbine. So due to high pressure and high temperature, it is turning the turbine. Then turbine is connected to compressor. Turbine basically runs the compressor. Now I will make a small kind of thing. It's called basically spool. Spool means this thing is basically known as spool or shaft. Spool or shaft that connects the compressor to turbine. So turbine is basically where expansion happens. So here compression, here combustion, and here expansion. Expansion means gas now expands. So here it was air, and here it will be gas. Here it will be gas. Okay. Sometimes they also can use a word called flue gas. Flue gas. So after this turbine, suppose we want to make this thing a little bit more efficient. So we will add a small afterburner. There is a thing called afterburner. है ना? Afterburner. So afterburner again increases the temperature of the air. है ना? And afterburner, this is nozzles. Okay, these are basically nozzles. So in the previous case, there was the type of nozzle like the normal nozzle we have studied, D-level nozzle, or you can say converging, diverging, CD nozzles. But right now in this case, variable area nozzles are there. Variable area nozzles are there. They can change or decrease or increase their area. So variable area nozzles are there. So this will be the basically all case. Now there are various other things. Now inlet we have considered is inlet nozzles, afterburner, water heat exchanger and intercooler. Okay. First of all, let me tell you a kind of intercooler thing. Now this whole engine becomes hot. So sometimes what happens, like some of the air is being inserted into a kind of pipe in above. Okay, let me draw into the next page. That will good. Okay. So in the next page, suppose I'm drawing it. Nothing. It's two things I'm making. One is heat exchanger, one is this intercooler type. Both are almost kind of same thing. So suppose this is the engine. Engine will start from here. Okay. There will be two things, core and bypass. Core and bypass. So some of the air will be going into the bypass. So this is cool air. This is what? Cool air. Okay. This is again going bypass. Okay. And in core, what happens? Suppose this is the, okay, not with this. I will draw with black. No. Suppose this is the combustion chamber. So what is happening? Some air, all the air basically what is coming, this is cool air. Now cool air is going into bypass. Cool air is also coming to the compressor. But in combustion chamber, this same air is heated and this hot air. Okay, so I will tell you this is the hot air and this is cool air. So whatever this hot air and cool air combination will be there, this will be now hot air, hot air. So now here hot air plus cool air combination will be there. So red plus blue is what? Red plus blue is basically, red plus blue color is basically known as orange color. Where is orange color? Yes, this is orange color. Okay, so some of this is the flue gases. Okay, hot plus cold, hot plus cold. So what is happening? This cool air is basically making it a little bit more energy efficient. Like see, whenever temperature increases up to very high speed, then performance changes and performance degrades. So this cool air basically reduce that performance issue. So that is the basically called intercooler and also heat exchanger. Okay. Now two things, two types of cycle are there. Gas turbine cycle is of two types. One is basically known as open cycle gas turbine. Open cycle gas turbine. Like whatever we are seeing. This is open cycle gas turbine. Okay. Here this is also open, this is also open. Then there is closed cycle gas turbine. In closed cycle gas turbine, what have closed cycle gas turbine is basically industrial plants. In industry also there is an industrial plant is there. So open cycle means open. Suppose I'm writing this open cycle. So in open cycle, what happens? In open cycle, it is air coming through inlet, air through inlet. Then it is compressed. Then it is burnt. Then it is expanded. Then finally released. Finally released, or you can say exhaust. What we do? Exhaust. So here the important point is that every time fresh air is introduced and burnt gases are exhausted into atmosphere. So about exhaust gases we don't have to worry about because all the exhaust gases are going into environment. Although we want to care about environment, not to care about this exhaust gases because exhaust gases will be there. That's why now green energy systems, hydrogen combustion system, they are coming so that our environment remains unpolluted. So otherwise technically in open cycle we don't have to worry about exhaust. So but in closed cycle what happens? In closed cycle it's same working fluid. Same working fluid. Working fluid means this final hot gases. Same working fluid means hot gases. Okay. Same working fluid, hot gases are again after being expanded to nozzle after being expanded to nozzle is introduced back to the introduced or fed into inlet again so basically whatever air is coming from here now it will be again added to inlet. Huh? Now whatever is going again in the engine is basically polluted gas because after combustion some byproducts are there, है ना? Some pollutants also there. Those pollutants can degrade the compressor blades, है ना? This turbine blades. Temperature can be sufficiently low because hot gases are difficult to compress. You cannot compress hot gas easily. Okay, now this line I am writing here. Always remember this. Compressing hot gas hot gas is difficult than cold gas. Than cold gas. So cold gases are easily to compress, and after compression, it is more and more cold. So this kind of thing is there. So some kind of our assumptions will be there. We will study open cycle. Okay, what we will study? We will study open cycle because that open cycle is basically known as Brayton cycle. It's called Brayton cycle. Now some analysis I am giving you assumptions for ideal cycle. Ideal cycle, although there is no such thing called ideal cycle, but still assumptions for ideal cycle. So like first thing assumption is process of compression and expansion. Process of compression and expansion in compressor and turbine, obviously in compressor and turbine respectively, in compressor and turbine respectively is isentropic in nature. It will be isentropic nature. Huh? The second will be axial velocity of working fluid must remain same. Axial velocity of working fluid must remain same. And then there is pressure losses should be negligible, although there are very much pressure losses. But what we will be conducting, so pressure loss is negligible. Pressure loss is negligible in diffuser, combustion chamber, etc. Now working fluid should be homogeneous. Now these are the absurd thing. Working fluid should be homogeneous. Should be homogeneous and perfect gas. Perfect gas means we can use the formula PV equal to RT or P equal to rho RT. That's why in our whole the propulsion we can use this formula PV equal to RT, P equal to rho RT. Otherwise, in the real cycles, these formula don't work. What formula is used? Van der Waals equation is used. P plus A upon V square, this formula. Okay, that's it. These are the important assumptions. Now, if you see this, so this simple gas turbine, if I give the number, like see, this is suppose a kind of compressor. Suppose this is the air which is coming. This is point number 2, inlet of compressor. Point number 3, which is outlet of compressor. After outlet, where it goes? After outlet, it goes to combustion chamber. And after combustion chamber, it comes to turbine inlet. Turbine inlet. This is basically compressor. And this is basically turbine. And compressor and turbine are connected with a shaft. Got it? And then they are connected with combustion chamber also. And after this is connected, turbine is connected to nozzle. Connected to nozzle. Right? Okay. So if I give the number, this is 2, this can be called as 3. Then this can be called as 4. So basically this process, 2 to 3 is a process. 2 to 3 is process of compression. 3 to 4 is basically combustion or heat addition. 4 to 5 is basically You can say 3, then 4, 3 to 4. 4 to 5 basically expansion. And after 5 also it is going on. So if I write this 1 to 2, 1 to 2 is basically you can say inlet of air. This is basically you can say in diffuser portion. So we are not going to discuss diffuser because we are going to see only this unit, compression, combustion and expansion. Now 2 to 3 is basically known as compression, and that compression is what in nature? This is isentropic in nature. Then 3 to 4 is basically known as heat addition. Heat addition is also isentropic in nature. Heat addition. Then 4 to 5 is basically known as expansion, or you can say turbine work. Turbine work. How much work has been done? This can be called compression. That means compressor work. Compressor work, heat addition, turbine work. So what will be net work output? Net work output. It is basically work of turbine minus work of compression. Work of turbine minus work of compressor. So we can say how much thing is there. So this kind of cycle, this cycle is basically Joule cycle or Brayton cycle. Joule cycle, Brayton cycle. This is basically Joule cycle. It's also same, or you can say Brayton cycle. There are various cycles. Otto cycle is there for diesel engine, Stirling cycle is there. Yeah. So now the next thing is that we have to write the formulas. Okay. So write the formula. Let's make this a little bit fast. Okay. Two, 3, 4, 5, 6. What is 6? Nothing is 6. This is 3, and this is 4, no? This is 5, and after 5 it is going. So 2 can be called as compressor inlet. Compressor inlet. 3 can be called as compressor outlet. Compressor outlet. And you can say combustion chamber inlet. Combustor, I am saying the word combustor inlet. And 4 can be called as combustor outlet. But at the same time, it is also turbine inlet. 5 can be called as turbine outlet. But here it is also called nozzle inlet. So technically, these are the basic terms of making a cycle. Now, work, if you want to consider, what is work? So work is also, we all know that work is basically enthalpy. This is what? Enthalpy. And enthalpy is what? Enthalpy is Cp delta T. Cp delta T, change in temperature. So this is here W, work is basically, W is work transfer per unit mass flow rate. Work transfer per unit mass flow rate. Okay. So WC, that means compressor work. Compressor work. So compressor work can be written as WC, or in the terms of this 1, 2, we can write it W2. W2 at 2. What is the basically thing? Or you can say 2, 3. W2, 3 is basically H3 minus H2. That is basically Cp T3 minus T2. T3 minus T2. Then there is thing heat addition. Heat addition can be called as Q. Q is basically heat addition. Heat addition can be called as Q34 because in the 3, 4 it is happening. So Q34 is basically H4 minus H3. So it is basically Cp T4 minus T3. Okay. Then the rest is WT. WT is basically turbine work. Now in turbine work, I will tell you a little bit thing. Now in turbine work, this 4 is having the high temperature, 5 is low temperature. Okay. So and also it is working in different. So it will be called as W45. Okay. 4, 5, but it will be H4 minus H5, not H5 minus H4. Okay. So H4 minus H5. Basically, you see from higher energy to lower energy, we always discuss. In 2, 3, 3 is having the high energy, 2 is low energy. Okay. So that's why 3 minus 2. But in 4, 5, 4 has the high energy, 5 has the low energy. 4 minus 5. So it will be Cp T4 minus T5. Right. Now net work output. Net work output, I told you the previous slide also that it is Wt minus Wc. That means Cp T4 minus T5 minus Cp T3 minus T2. That is basically net work output. So what is the efficiency? If anyone will ask you what is the efficiency. So efficiency formula is basically how much heat you supplied. Heat you supplied. And based on heat supplied, how much power you have or work you have generated. Net work output. Net work output. So net work output formula, you already know this is the Cp T4 minus T5 minus Cp T3 minus T2 divided by heat supplied. Heat supplied is basically what? Cp T4 minus T3. Okay, T4 minus T3. That is the case of cycle efficiency. This can be called a cycle efficiency. Or you can say Brayton cycle efficiency. If anyone knows Brayton cycle efficiency. Okay. Fine. Now we will be giving you a little bit more idea of like how this whole system works. Various types of turbines are there, various types of compressors are there. We will start the jet analysis from tomorrow onwards. And so tomorrow will be their class because yesterday there was no class. So tomorrow will definitely be their class. And tomorrow we will start jet engine analysis. So you guys got an idea now that how this gas turbine is there. So suppose this is a basically simple turbojet. In simple turbojet, there is nothing less or nothing more. Only one inlet will be there and one nozzle will be there. Rest everything is this whole cycle. Okay, but velocity will be there. Okay, in that case, in compression we will see then velocity triangle. When turbine we will see then velocity triangle. So velocities will be there. Okay, so that will be the case. So must join the tomorrow's class because tomorrow we will be starting the jet engine analysis. And in jet engine analysis, we will be discussing about this starting of types of engine, then some pressure ratios, temperature ratio, some simple kind of terms we will be giving. Suppose pressure ratio. So P3 by P2. Okay, P3 by P2 is basically known as R, small r. Okay, so P3 by P2 is pressure ratio across compressor, how efficiency changes across compressor, and how temperature ratio changes across compressor. These kind of topics will be discussed. Yes, Kavya. Tomorrow we will be 6:30 because tomorrow there is no event. Okay, to everyone, tomorrow the class will be 6:30. Okay, so please join at 6:30, and we will start the jet engine analysis. And also tomorrow we will be finishing jet engine analysis. So please have a little bit of that patience of till 8 o'clock or 8 or 8:15. I'm just finishing it today here because it will be like incomplete topic. So tomorrow 6:30 p.m. we will be doing that. Okay. Thank you everyone. We'll see you tomorrow. And one more thing, please tell the WhatsApp team your email IDs. They will be providing you email ID with password for mock test series. Okay, so that you can log in there and start performing the test.